Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 35 of NEET physics paper 2017. Hello students, let us solve question number 35. A spherical black body with a radius of 12 centimeter, that is a black body. This is a spherical black body whose radius is 12 centimeter. So I'll write the radius is 12 centimeter. Radiates 250 watt power at 500 Kelvin. So the temperature of this body is 500 Kelvin, and radiating, how much power it is radiating? The power being radiated power is 450 watt. Okay, if the radius were halved, if that radius is halved, that means if the sphere is reduced to smaller size, for example this one, if the radius is reduced to half, that means here the radius is 6 centimeter, from 12 to 6, and the temperature doubled. So the temperature here was 500 and now here it will be double, that means 1000 Kelvin. The power radiated in watt will be, so if I write this is R1 and this is T1 and this is P1 and this is R2 and this is T2, and we are asked to find power radiated, that is P2. How much power will be radiated in this case? That is asked. So you must have a relationship between this power radiated and the radius and the temperature of the body. From Stephen's law of heat radiation, Stephen's law of radiation, we know that the rate of emission, that is the amount of heat emitted per second, is directly proportional to the area of the body, the temperature of the body, fourth power of the temperature of the body, and also the, obviously this is not changing, but it depends on the emissive power of the body, that is the emissive coefficient, that emissivity, E also is involved, emissivity, the coefficient of emission, E. So from here, this one is the heat energy radiated per second. So this is the, if I think of the unit, then this is joule per second and this is power. This is actually the power. So the power, and also the, if I think of this as power, then power is proportional to AET⁴, because this is the same black body and only the change is in terms of the radius. So this E factor is not going to change, and E for the black body, the E for the black body is found to be 1. Okay, E for the black body is found to be 1. So this will also become 1. So if this is 1, then the power is proportional to AT⁴. This relation can be used to find the answer. So now what we'll do, we'll use this relation that P is proportional to A t raised to 4, and A is the area or surface area of the sphere, and that surface area is 4 pi r square t raised to 4. That means P is proportional to r square t raised to 4. This relation is. Then I have two cases. One is having radius r1, then other is r2. If I call this is 12, this is calling 6. But anyway, if I call this radius r, then this is actually r by 2. I don't have to write the actual numbers because this is just a ratio you are asked to find. If it is 12, it is 6 or 10 or 5, it doesn't matter. R and r by 2. And the temperature here is, suppose that it is T, here it is 2T. This is the situation in the first and second case. So I'll write that P2 or P1, the power radiated in the second case is asked. This one is asked. This is equals to R2 square and T2 raised to 4, this relation, divided by, similarly for P1, it will become only 1, so R1 square T1 raised to 4. And if I see that this R2 is half of this one, so this I'll put as R by 2 square, so it is R square divided by 4, and this will become only R square because I have considered this R. T to the power 4 and T1 to the power 4, so T2 is 2T, so 2T to the power 4 divided by T to the power 4. If I solve this, then this r square will cancel and T2 will also cancel, and that will give me 2 raised to 4 divided by 4, which is 16 divided by 4, which is this is 4 because this is 16 by 4, so P2 will become 4 times P1. So the power radiated in the second case here will be how much time? 4 times P1. P1 is 450 watt, so therefore 4 into 450, so it is 900 plus 900, that is 1800 watt. So this is the answer to this question, and this is option number 4. Okay, thank you.